Hey guys, this is chapter 2.6, Building Functions for Real-World Problems. So in this section, you're going to be given a problem and you're going to want to make a model to help you solve different applications of it. So in this first section, we're just going to be talking about one-dimensional problems using the distance formula. And next we'll go on to two-dimensional using like y equals x squared. And then we'll go on to three-dimensional problems later. So first, one-dimensional problems. So these are basically going to ask you to create a model with a given situation. It's going to want you to create a mathematical model and then use it to find certain values at specific points. So the first step when you get these problems is you want to create a general formula. So for the one-dimensional problems, our general formula is going to be the distance formula, which we covered earlier. So first, write out that formula, and then you want to make it specific to this problem. So from this problem, it says we want to find the distance from the origin being right here, to a point along this parabola. So since we have the origin, x1 and y1 are going to be 0 and 0 because the origin is located at the coordinates 0, 0. So you can plug in x minus 0 squared plus y minus 0 squared, and this is going to give you just root x squared plus y squared once you simplify it. So that's going to be your general formula for this problem. So now that you have your general formula up here, you're going to want to have all x's in this equation so it's solvable. So you're going to want to plug in the equation it gives you for your y. So it tells us that your equation is y equals x squared minus 1. So what that means is y is the exact same thing as x squared minus 1. So basically wherever we see y over here, we can plug in x squared minus 1. So we can do that here. Distance equals root x squared, still going to be x, plus, and then plug in y for the equation, x squared minus 1 squared. After you simplify that out, you're going to get distance equals the root of x to the fourth minus x squared plus 1. So now this equation here that we just got is going to be called your model. So the model is really important because this is the hardest part. So once you get your model, you can carry on and you can use it for these applications. So if it asks you to find what's the distance when x equals 1, you can plug in 1 for x and you can solve the problem. So the first step, or the first main thing you have to do in these problems is to get this model right here. So the next step is going to be using this model for applications. So like part C in the problem might say, so now that you have this model, what is the distance from the origin when x equals root 2 over 2? So now you can solve this problem because now you have the model function. So now all you have to do is plug in root 2 over 2 for x in your model equation. So here I'm going to work out the problem. Okay, so you just have to plug in x equals root 2 over 2 every time you see x. So you got your root 2 over 2 to the fourth, and then it's minus x squared, so minus root 2 over 2 squared, and then plus 1. You guys can do the math. It'll come down to root 1/4 minus 1/2 plus 1. And that'll simplify out to root 3 over 2. So that's your answer. The distance from the origin to x equals root 2 over 2 with this equation is going to give you root 3 over 2. So if you want to see what this problem is actually asking for, you can draw in your parabola, which is just x squared minus 1. And then it's asking for the distance from the origin, which is right here, to root 2 over 2, which is roughly here. And so this is the distance you're solving for. So by creating that model equation we made specific for this graph and this problem, Any x value you plug in around here, you can find by plugging it into your model equation, you could find this distance to any of these points. So your next question might be, okay, well, what if you're not starting from the origin? What if you're starting from this point, for example, and you have the same parabola, and you want to know the distance to any point along the parabola starting at here rather than the origin? The solution to that problem is you have to go back to step A, which is where you get your general formula. So in this problem, since you're finding the distance between 2 points, you're going to be using the distance formula. So if you write out the distance formula, it's x minus x1 squared plus y minus y1 squared. So if you remember for this problem, right after we did that, we plugged in 0 for x1 and 0 for y1 because we were going from the origin. So now for this problem, since you want to go from the point 0, 2, we're just going to plug in those coordinates for that. So it's going to be x minus 0 squared, like the previous problem, but now instead of y minus 0, it's going to be y minus 2 squared. And so here you can simplify it down, and you're going to get root x squared plus y squared minus 4y plus 4. And then you guys remember step B was to plug in the equation for y so you can deal with all x's. So you're going to do the same thing here. It's just going to be a little more complicated because you have 3 y's rather than 1. So you're just going to write it out again, x squared plus, and then every time you see a y, you have to plug in the equation of the graph, which was y equals x squared minus 1. So remember, these are equivalent, so anytime you see y, you plug in x squared minus 1. So you're going to have x squared plus, and then you have y squared. You have y squared here, so for that you're going to plug in x squared minus 1 squared, and then minus 4y, so minus 4 x squared minus 1. Sorry, move it over a little bit. And then your last thing is just plus 4, sorry. Extend the radical. And then you can just simplify this down. And then this is the simplified form. So you end up with root x to the 4th minus 5x squared plus 8. So this is going to be your new model equation for the problem. So then if it asks you to find the distance from our point that we're using now, which was 0, 2, it says find the distance from the point 0, 2 to the position when x equals root 2 over 2 on the graph, like we did in the previous problem. So this one you're just going to do the same thing. You just plug root 2 over 2 in every time you see x. And then you simplify it down. And so it's basically the same thing, just a few more steps to get this down. And so that's basically it for the one-dimensional distance problems. So next we're going to be doing two-dimensional problems dealing with parabolas and area rather than just plain distance. So I'll see you next time.